Hello class, and welcome back. In today's lesson, we are going to talk about the meaning of lambda. Now, in our previous lesson, we are solving problems, constraint problems, using the Lagrange multiplier. So the question is, what is the meaning of lambda or the Lagrange? Now, for us to understand the meaning, first of all, we should do some calculations. And in doing our calculations, we are going to consider Usuma Limited, which faces the minimization problem, which is total cost is equal to 3x squared plus 6y squared minus xy. Thereafter, we have been requested to determine the cost minimizing output level of commodity X and Y, subject to the condition that the total output must be equal to 18 units using the Lagrange multiplier. And lastly, we have been asked to calculate the minimum total cost. Okay, let's continue. Now, the earlier on stated that the first thing that you should do, you should take your constraint equation, which is x plus y minus 18. Then multiply it by lambda. Now that is lambda, the Greek symbol. Next, after you have multiplied, your constraint equation will look like that. It will look like that. X lambda plus y lambda minus 18 lambda. Next, you are going to add this, your new constraint equation, to your total cost function. So it will read 3x squared plus 6y squared minus xy plus x lambda plus y lambda minus 18 lambda. After doing that, your next step now, you're going to differentiate this, your total cost objective function, in terms of x, in terms of y, and in terms of lambda. So let's differentiate in terms of x. It's going to be the total cost. Now remember, the equation that we are differentiating is total cost. So here it should read the total cost. And we are differentiating in terms of x, so it will be the total cost over dx. Okay, so we are just going to concentrate where there is x. The first one is 3x squared. So 2 times 3 is 6. And we know the rule. The one x will go and it will just remain x. The other one, we target x, we go to this one. This x will disappear and will just remain with negative y. Then here, the x will disappear, will just remain with lambda. This should be equated to 0. Okay. We have differentiated in terms of x. Let's differentiate in terms of y. Sorry, that should be y, not x. That should be y, not x. That should be y. The second one should be differentiated in terms of y. So let me put y there. Yeah, I've put y. I've put y. Okay. So we are differentiating in terms of y. So it is going to be the total cost over dy is equal to. So we are getting where there is actually there is our main focus is where there is y. So here there is 6y squared. So 2 times 6 it's 12. 1y will go remain with 1y. Minus, here the y will go remain with negative x. Here the y will go remain with lambda equals to 0. And lastly, we are going to differentiate in terms of lambda. So we are differentiating in terms of lambda, not in terms of x. That's an error. So let's differentiate in terms of lambda in the final part. So this one we are differentiating in terms of y, and this one we are differentiating in terms of lambda. Okay, thank you very much, and sorry for that inconvenience. Okay, so we have differentiated the first one in terms of x, and it has given us that. We have differentiated the second one in terms of y, it has given us that one, and we have differentiated the other one in terms of lambda, and that's given us that. Okay, the next step is that we are going to get a first equation and the second equation, and in each case we are going to make lambda the subject formula. So the first one will look like that. Lambda will be the subject, then this our 6x will cross the equal sign and become negative x, 6x. This our y will cross the equal sign and become our positive y. So we have made lambda the subject in the first equation. Next, we are checking this second equation, where and here it should be y. It should be y. Here it should lead y. It should lead y. Thank you. Yeah, it should lead y. So now in this one we are saying lambda will be the subject. This y 12y will close the equal sign and will be negative y. The essence is to make lambda the subject. Then this x will close the equal sign and will become positive x. After that, then we are going to equate lambda to lambda. In other words, we are saying that this equation and this equation should be equated. And if we equate, it's going to be like that. So we are going to check this negative 6x plus y, it will be here, is equal to negative 12y plus x. That's what we have done. Next, we are going to collect the like terms. So negative 6x is going to call this x. It will close back and become positive minus x plus y. This y is going to call the 12y, which is on the other side, and it's going to be a positive y, which is equal to 0. After that, reduce it. Negative 6x minus x is giving us negative 7x plus y plus 12y is giving us 13y, which is equal to 0. So we have formulated a fourth equation. Remember, this is the first one, this is the second one, and this is the third one. So this one which you have formulated is a fourth equation. Okay, let's continue. What will be our next step? We are going to do that. We are going to take the fourth equation and solve it simultaneously with the third equation. So now in these two, we are going to eliminate one variable. Let's say we want to eliminate x. So since we want to eliminate x, we are going to multiply 7. We are going to take this 7, put it there, and multiply it with all the elements that are in this function. So it will be like that. Remember, this one just remain the way it is, 7x plus 13y. So it will remain 7x plus 13y is equal to 0. This one will multiply 7 times x, it will be 7x. 7 times y, 7y. 7 times 18, it will be 128, 126. Now, we want to eliminate x. Now remember, this is a negative number and this is a positive number. So if we want to eliminate x, we are going to add. That's why I've put my plus here. So that this and this will go to cancel. Then we are going to remain with this. 13 plus 7 is going to give us 20. So it's going to be 20. Then 0 plus 126, 126. Now, we have to solve for y. So we are going to divide on both sides by 20. 20 divided by 20. So, and 20 will go into 126. So it will be, our y is going to be 6.3. When we divide 20 into 126, our y will be 6.3. Next, we are going to solve now for x. So remember, I have already solved for x, for y. So where there is x, we just put the value of y, which is 6.3, where there is y. And it will be like that, like as follows. X is equal to 18 minus 6.3. And this is going to give us x is equal to 11.7. So our value for x is 11.7. And our value for y is 6.3. Okay. So the next thing we are going to do is we are going now to find our minimum total cost, because that was our second equation. Now to find the minimum total cost, we are going to take the total cost equation, which is 3x squared plus 6y squared minus xy. So where there is x, we are going to substitute by 11.7. Where there is y, we are going to substitute by 6.3. So it will be like that. Total cost is equal to 3 open bracket 11.7 close bracket to the power 2 plus 6 open bracket 6.3 close bracket to the power 2 minus 11.7 times 6.3, and it's giving us our total cost is 573.75.1. Okay, now let's continue. Let's calculate the lambda, the value of lambda. So how are we going to calculate the value of lambda? We are going to check, to calculate the lambda, we take the first function we differentiated in terms of x. Okay, that equation. X is equal to negative 6x plus y. Then we are going to substitute where there is x, we put 11.7, where there is y, we put 6.3. And like that. Then if we do our math, it's going to be negative 63.9. That will be our value of lambda. Okay, now that we have calculated the value of lambda, let's understand the meaning of lambda. Okay, what is the meaning of lambda, or the meaning of this Lagrange? Okay, the meaning of lambda is that if the constant equation is increased or decreased by 1 unit, profit or total cost will increase by 63.9 or decrease by 63.9. Okay, we have calculated that the value of lambda is 63.9. Now the issue is this: let's say if we are considering the profit equation, the constant is increased by just 1 unit, then the total profit that we are going to get will increase by 63.9. Now in this case, it is a total cost equation, or it's the total cost that we are calculating. If we add 1 unit to the constant equation, then the total cost will increase by 63.9 or decrease by 63.9 if at all we reduce the constant equation by 1. If we add it by 1, we are going to increase the total cost by 63.9. If we reduce it by 1, we are going to decrease the total cost by 63.9. This is what I'm saying. In the example in the above given constant, which is x plus y is equal to 18, the total cost was 575.1. Now, listen to this. If x plus y is increased, becomes equal to 19. Instead of equal to 18, becomes equal to 19. The total cost will increase by 63. So, that will mean that's 575.1 plus 69, that will be 3.9, that will be the increase. And if x plus y becomes equal to 17, we reduce it by 1, from 18 to 1. The total cost will decrease by 63.9, meaning 575.1 minus 63.9. So that is the meaning of lambda. The meaning of lambda in a nutshell, we are saying that if the constant equation is increased by 1, then the total cost will increase by 63.9. If the total cost equation, the constant equation, is decreased by 1, then the total cost will decrease by 63.9. I will repeat that. The meaning of lambda in this case is that if the constant equation x plus y is equal to 18 is increased by 1, then the total cost will also increase by 63.9. If the constant equation is decreased by 1, x plus y becomes equal to 17. Then what will happen is that the total cost will also decrease by 63.9. That's the meaning of lambda. Let's hope you have understood the lesson. If you haven't understood, listen to it over and over until it gets into your head. Thank you very much, and God bless you.